Greetings, fellow muckers. Today we'll be looking at a classical model problem. Just a few facts about the classical model. The shape of the aggregate supply is always vertical at full employment. The short run Phillips curve is vertical, as long as the long run Phillips curve is also vertical. Price expectations in the classical model is perfect information. And those are just some quick facts about the classical model. Now, the problem. We are given a supply function, ns, is equal to 20 plus 3w over p. We are given a production function of y is equal to 2500, 2500 minus n squared divided by 10 plus 20n. Part A. Solve for the equilibrium values of the variables n, y, w over p, and mpn. Part B. Now assume the labor demand and supply functions change to nd is equal to 130 minus 5w over p, and ns is equal to 100 and is equal to 10 plus 3 w over p. Solve for the new equilibrium values of n, y, w over p, and mpn. Now take a few minutes, pause this video, and solve this problem. Welcome back. Hopefully you were able to solve this problem. Now let's solve it together. So, firstly, from our original two equations given, how do we find our MPN, or our marginal product of labor? Well, a marginal product of labor, or MPN, is just the derivative of the production function. So, this is the derivative of the production function, so y, and we're going to take the derivative with respect to n. This is going to be equal to an MPN, and this is going to be equal to negative 1/5 n plus 20. So that is our equation for our marginal product of labor. And our marginal product of labor in the classical model is going to be equal to real wage, or W over P. So W over P is real wage. So this is real wage. And that's going to be equal to W over P. And our marginal product of labor is equal to that. So now that we know that, we can find our demand function, a labor demand function. So to do that, we set negative 1/5 n plus 20 equal to W over P. And then from here, we can times everything by 5. So by 5. We're going to get, actually, before that, I got one step ahead. Before that, let's make it easier. Let's move the 1/5 n over to the right, and then let's move this W over P to the left. So to do the negative 1/5 to the right, we add 1/5 to the right and subtract. So 1 W over P to get to the left. So we get 20 minus W over P is equal to 1/5 n. And then from here, we can times everything by 5 to find our demand function. So we get our demand is going to be equal to 100 minus 5w over p. And that is our demand function. Now that we found our demand function, one second, we can solve for w over p, or real wage. And how do we do that? Well, we just set our demand function equal to our supply function, and this will give us our demand 100 minus 5w over p is going to be equal to our supply function, which was 20 plus 3 w over p. And now that we found that, let's simplify. We're going to get 80 is going to be equal to 8w over p. Now we can find w over p by taking 1/8 of both sides. So w over p is going to be equal to 10. Oh, w over p. So, no. So our real wage in this case is going to be equal to 10. And to find our n is going to be equal, we can plug it in for either supply or demand or real wage of 10. So let's just do demand. And you will see if you plugged it into either demand or supply, you will get the same n value. So let's do 100 minus 5 times 10 is going to be equal to 50. This is going to be equal to n. And finally, to find our y value at equilibrium, we just plug in our values we just discovered into our production function, so just n. So we get y is going to be equal to 2500 minus 50 squared divided by 10 plus 20 times 50, and this is going to be equal to 3,250, and that is our solution. So for equilibrium of y, it's going to be 3,250. Our equilibrium of n is going to be 50. Our real wage, or w over p, is going to be 10. Our demand function is 100 minus 5w over p. And that in our MPN, yes, we need to find our MPN value. So let's just do this. MPN is going to be equal to negative 1/5 times 50 plus 20, and this is going to be equal to 10, which should be equal to a real wage, which makes sense because MPN, or marginal product of labor, is equal to W over P, or real wage. So that is the solution for part A. Now part B. Now assume the labor demand and supply functions change to ND is equal to 130 minus 5 W over P, and NS is equal to 10 plus 3 W over P. Solve for the new equilibrium values of N, Y, W over P, and MPN. So, first things first, since we are given our supply and our demand functions, we can find our real wage of W over P right off the bat. So, remember that MPN is equal to W over P, and the demand is going to be equal to a supply. So since our demand 130 minus 5 W over P is equal to a supply 10 plus 3 W over P, we'll get 120 is equal to 8 W over P. We solve for W over P by dividing by 1/8 to both sides. And we'll get W over P is equal to 15. Now, we can solve for our N by plugging in our real wage into either our demand or supply function. So we can do a supply this time. NS is equal to 10 plus 3 times 15, which gives us 55 is equal to N. And then we'll see MPN is equal to W over P. So MPN is equal to 15 as well. And our last value we need to solve for is our Y value. And how do we find our Y value? Well, it's the same Y as for part A. We just get new demand and supply functions. So we'll plug in our new N to Y. So Y is equal to 2500 minus 55 squared over 10 plus 20 times 55, and we get a value of 3297.5 as our Y at equilibrium. And is that all the values? It's all for N, Y, WP, and MPN. Yep, and that's it. So that's the solution to the problem. I hope this video helped. If it did, please consider subscribing and liking.